Hello everyone, welcome back. In today's video, we will be exploring PGVector, an extension for PostgreSQL that allows us to store and query high dimensional vector data very efficiently. If you're working on machine learning models or AI applications, PGVector can be a very powerful tool. So what is a PGVector? PGVector is a PostgreSQL extension that enables the storage and similarity search of high dimensional vectors. It's especially useful for applications like recommendation systems, image retrieval, natural language processing, where vector representations are key. PGVector store your vectors with the rest of your data. It supports exact and approximate nearest neighbor search, single precision, half precision, binary, and sparse vectors. It supports L2 distance, cosine distance, Hamming distance, etc. Plus also its asset compliance. So let's dive in. So in this video, I'll show you how you can set up your PGVector with your existing Postgres database. So the requirement is your system should have the Postgres database installed and it supports version 12 plus. So if I go PSQL Postgres and it says select version, I have 14. So yes, 14.5. I will install the PGVector or set up PGVector in this. So you have to go to your temp directory, which I'm in, and here you can clone the GitHub repo of PGVector. And at the time of recording, I'm getting the branch 0.7.0. So it's cloning the PGVector, and it'll be quick, yeah. So it clone and cd PGVector. So once you are in that directory, you can run make install. First make, and then you can run make install. So after running make and make install, you go back to your Postgres database or your database where you want to enable it, and you say create extension vector, and it says it already exists. So I'll choose another database. I'll say go to web app. Okay, and here I'll say create extension vector, and it says no schema is selected, so I will set the schema as public. Okay, and now I can install the extension. So extension is installed. And now once I have the extension, what I can do with it, I can play around, I can create tables, and I can insert vectors in it. So I'm going to copy some query directly. So I'm creating a table called as items. Here ID is big serial primary key, and I'm creating a vector embedding of size 3. Okay, so if I see the structure of the table, I say items. So you say embedding vector 3, and the ID is primary key, which is auto incremented. Okay, and now I create in this table, I create values. So what I'll create here, I say insert into this table items embedding values as 1 2 3 4 5 6 in the form of vectors or arrays. So once this is inserted, you can do a select star from items. Okay, it will give you embedding, but it's not giving you like what we will do with the embeddings, right? So you can find like these embeddings are the vector, but what you can do, so you have, let's say you have a data and you want to know how far that data is, like basically you want to calculate an L2 distance or L1 distance or Hamming distance on that data. So how you can do that? So here's a query. You say that select star from items, order by embeddings, and this is the data you are passing, and limit to 5, right? So you said like this is my data and I want to know the greatest or sorry, I want to know the nearest neighbors by L2 distance. So this is the closest and this is the farthest neighbor. This query we calculated L2 distance, but what and how it's bringing the L2 distance. So you see this symbol right on the screen, right, that I'm highlighting. So this is what calculating the L2 distance, and that's what you're getting on the screen. Another symbol is, let's say you want to calculate the L1 distance, so you can copy the same query and you can say that instead of using that symbol, you can say that this plus in between and the rest of the query and limit to 5. That's how you can get the L2 versus L1 difference. Like, and there are like other symbols to get the cosine difference. So if I change this symbol to equal to here, it will give you cosine difference. And how you can get the negative inner product, so you can use the symbol hash instead of equal to. So yeah, so that's how you can get it. How far exactly, or what is the actual distance between the data that you are passing and versus the current vector embedding. So you can do, you can say that select embedding, and this is this is the embedding you're passing, and you're saying as distance from items. So once you run that, it will give you the distance, right? The distance is 2 dot, you know, and 5 dot some decimal places. So second row is little far from the current data, and the first row is more closer, or you can say more similar to the what the data you are passing. So for example, let's say if I change this querying data, so here I'm saying that instead of 3 to 1, I'll pass 1 2 3 exactly. So what will happen in this case? So in this case, you are saying that my embedding is this, find me the distance from the actual or from the vectors that are stored in the database. So what will happen in this case, this, what is the distance from these two items? So from this particular storage table, the first row is exactly the same, so here it should give us the 0 distance, and for the second row the distance is little farther, so it will return that number. So as you can see, the distance for the first row or the first vector embedding is 0, like it is exactly the same, and the second row it's little far, so it returns that value. Similarly, if we change this to let's say 4 5 6 instead of 1 2 3, and now it's far from the first vector and very close or almost same as the second vector. Okay, so that's how you can get the distances. Okay, so that's how you can query the embeddings or vectors, and like there are multiple operations that you can perform. You can upsert vectors, update vectors, delete vectors. You can query L2 distance, L1 distance, which is recently added in 0.7.0. You can also query like cosine distance and inner products. So various queries that you can, or operations that you can perform. Thanks for watching. Thank you very much, and don't forget to hit subscribe button. Thank you.